Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain another example of paper 1 higher level IB chemistry. This would be the last example for this this year for paper 1 higher level. It is not guaranteed 100%. This question will appear in the exam, but at least through 4 examples that I have been explaining so far and from the past year papers that you've been working so far, you can actually feel and you can actually understand the pattern or the style of the IB chemistry that would prepare you for the exam that will happen soon. And also you can check or investigate what kind of topic that you're still struggling with, because the question always go by the order. I wish you a good luck with your exam and get the highest score. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. For my next video, I will try to compare what kind of topic that appears in the previous exams, past year papers from November 2023. I will compare a few years and different time zones, so we can actually check what kind of topic that usually appears in the exam or the weight per topic, so you can have the idea what kind of or how the question would be for the May 2024 exam. And now let's get started. Which statements are correct about a pure substance? It is always an element. It is incorrect because it can be compounds as well, like water, H2O. Its melting point is sharp as they melt at a specific temperature. More than one pure substance is present in heterogeneous mixture. Heterogeneous is a non-uniform composition made by different substances physically mixed together. So 2 and 3 are correct. The answer is C. 2.53 gram of sodium sulfate is dissolved to form 50 centimeter cube aqueous solution. What is the concentration of sodium ions in mole per decimeter cube? So for sodium sulfate, that would be Na plus, SO4 2 minus. So the compound would be Na to SO4. When it dissolves in water or aqueous solution, it produces Na plus and SO4 2 minus ion. This will be 2. And through the mass of sodium sulfate, we can find the mole, which is 2.53 divided by its molecular mass, which is 142.05. It's 0.0178 mole, because for 1 mole of sodium sulfate, it's 2 mole of sodium ion. So the mole of sodium ion would be 2 times 0.0178, which is 0.0356 mole. So to find the concentration of sodium ions, that would be mole divided by volume, which is 0.0356 divided by 0.05. It's 0.712. So the answer is B. Which statements are correct about real gases? Gas particles are considered to have negligible volume. Before that, let me explain. Ideal gases, described as moving particles with no volume and no intermolecular forces, and real gases take into account the small volume of particles and intermolecular forces that can cause deviation from the ideal behavior. So for the first option, it applies only to ideal gas, so it is incorrect. For the second option, at low temperatures, intermolecular forces exist. It's true, because at low temperature, condensed phase exists and intermolecular forces are significant. For the third option, at high pressure, real gases behave as ideal gases. It's incorrect. It is real gases behave like an ideal gases at high temperature and low pressure. Therefore, the answer only 2. Consider the reaction below occurring between copper and nitric acid. So copper react with nitric acid, produce copper nitrate, nitrogen dioxide gas, and then water. So what is the volume of NO2? So that would be PV nRT. So V would be nRT divided by V. But the problem is we have 2 mole right here. So one of these should be acting as a limiting reactant. So for copper is 1.50. For nitric acid is 7 mole. So for 1 mole of, for 1 Cu is 1.50 mole, but for nitric acid is 7 mole. So for 1 mole, or for 1 HNO3, it should be 1.75 mole. Therefore, the limiting reactant is Cu. So now, for the mole of nitrogen dioxide, we will refer to the Cu. So here is 2. Therefore, the mole of nitrogen dioxide is 3 mole. So now, let's put into the formula. So 3 times 8.31 times T 298 divided by, it should be pressure here. So pressure is 100 kilopascal. Okay, so the answer would be D. What is the relative atomic mass given by the mass spectrum below? So to find the relative atomic mass by the spectrum below, so that would be 22 times 1 plus 23 times 2 plus 25 times 5, okay, plus 26 times 1 plus 28 times 1 divided by 1 times 2 plus 2 plus 5 plus 1 plus 1, and you'll get 247 divided by 10, which is 24.7. Which energy transitions in the hydrogen emission spectrum has the highest frequency? Let's check for these A, B, C, D option. N equal to 1, and then this one N equal to 2, and then this one N equal to 3, and this one N equal to 4. So for option A, this from 3 to 1, this option A, and for option B, and for option C, and for option D. Transition D is the one with the greatest emission, because energy equal constant, Planck constant times frequency. So the greatest emission, the greatest the frequency. So the answer is D. Which statements about successive ionization energies of sodium are correct? Sodium with the electron number 11, the electron configuration will be 1s2, 2s2, 2p6, 3s1. So there will be a significant jump is expected after removing 1 electron from 3s1, from first ionization energy to second ionization energy, and another jump is expected after removing 1 electron from 2s1, from the 9th ionization energy to the 10th ionization energy. So now let's check. The first option, they show an increasing trend as the number of electrons removed increases. Correct, right? There is a significant jump from the second to the third ionization energy. No, from the first to second ionization energy. There is a significant jump from the 9th to the 10th ionization energy. Correct. So the answer is C. Which of the following statement is correct about zinc? Zinc with the electron number 30, the electron configuration is Ar, 4s2, 3d, 10. So it's fulfilled. It has no color. Therefore, this is not the answer. It has a high melting point. Correct. Because like most metal, the structure is a lattice of cations with free and delocalized electrons that has attraction electrostatic attraction forces. It is a bad conductor of heat. It is actually a good conductor and it has a delocalized electron. It can act as a catalyst to the presence of unpaired electron. It is not unpaired but paired because 3d10. So all the orbitals of d will be fulfilled by the electron. So it's a paired electron. So it is incorrect. The correct answer is B. Which statements are correct about Ti2 plus? Ti2 plus for Ti only with the electron number of 24. So Ar for S2 3d 2. So Ti2 plus would be Ar 3d 2. So it is paramagnetic. 1 2 3 4 5. So 1 electron, paramagnetic. Okay, correct. It is the metal cation present in TiCl6 2 minus. This would be negative 6 Cl and then equal to negative 2 minus. So this should be plus 4, right? So it's not plus 2 plus. So or plus. So option 2 is incorrect. It loses a 4s electron to become Ti3 plus. It should lose one more electron from D to become Ti3 plus, not from 4s. Therefore, the answer only 2. CrH2O63 plus is violet. Which statement about this transition metal complex ion is correct? If it is violet is observed, it is because of the absorption of yellow ochre. So the answer is C. The color of the complex ion is due to the absorption of energy corresponding to a wavelength near 580. So it's yellow. The answer is C. What is the name of Al2SO43? Al is aluminum and then SO4, this is sulfate ion. So the answer is A. Which species has the longest carbon to oxygen bond? CO2, double bond, CO, triple bond, CH3, COO minus, and then CO3, 2 minus. Okay, so this one double bond and triple bond, obviously no. So this has double and single, one single bond, one double bond, and this one has one double bond and two single bond. So for option C, intermediate bond between a single and a double bond. But for the option D, intermediate between two single bond and a double bond with greater contribution of the single bond. Therefore, the answer is D. Which is the correct combination for benzene? So this is benzene, and for every C has one bonded to one H. Okay, for sigma bond, let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of sigma bond, and pi bond 1, 2, 3. So 3. sp2. So this every single C has 3 domain, right? So it's sp2. The answer is D. Consider the chemical reaction below. KClO3 produce KCl and oxygen. So breaking up the solid will require energy. So it is an endothermic reaction. So delta H will be positive. And from solid to gas, increasing disorder. So the entropy will increase. So delta S will be positive. And what about ionic? You know KClO3. These ions form a crystal lattice structure. So it is formed in an ionic structure. So the answer is A. Number 15, what is the enthalpy change for the complete combustion of propane gas in kilojoule per mole? So the reaction would be propane C3H8 react with oxygen, produce CO2, complete, yeah? So produce CO2 plus H2O. Let's balance them. This will be 4, this will be 3, and this will be 5. So delta H will be 3 times CO2 plus 4 times H2O minus C3H8 plus 5 times oxygen. So the answer would be B. What is the enthalpy change in kilojoule per mole for the chemical reaction below? So delta H will be N triple bond N plus 3H2 minus NH3 would be 2, so that would be 6NH. So that would be 945 plus 3 times 436 minus 6 times 391. The answer would be D. Consider the Born-Haber cycle below. Which calculation represents the lattice enthalpy of mx2? So this is the direct route, and this would be indirect route. As you can see, F, it has a different direction. So min F plus G plus H plus I plus J and then plus K. The answer is A, because except F, all of them has the same direction with this indirect route. The standard entropy change for the complete combustion of an unknown compound is X in J per K mole, and its standard enthalpy change is Y in kilojoule per mole. What is the Gibbs free energy in kilojoule per mole? It means X should be divided by 1000, because should be in kilojoule per mole, and the enthalpy change is already in kilojoule per mole. And for T should be 283 Kelvin. So delta G is delta H minus T delta S. So this Y and then this one X. So the equation would be Y minus 283X divided by 1000. The answer is C. Consider the chemical reaction given below. Which statements are correct for the rate of this chemical reaction? So the rate of reaction equal to negative delta concentration of P4O6, reactant, divided by delta T equal to negative delta HCl divided by 12 delta T, because the coefficient is 12. Therefore, the rate of consumptions of P4O6, it's equal to 1 times 12 times the rate of consumption of HCl. Okay, so therefore the rate of consumptions of P4O6 is greater than that of HCl. This one, it's incorrect. The production rate of Cl2 is greater than that the consumption rate of P4O6. It means this one is 6 times greater. Okay, so for this one, 6 times greater for the production of Cl2O is the same concept with this. Okay, so this one is correct. The rate of this chemical reaction can be monitored by controlling the pH as time goes by. So the pH should increase, right, as the acid is consumed. So monitoring the pH change is a method that can be used to monitor the rate of reaction. Therefore, option 2 and 3 are correct. Choose the correct statement based on the energy profile below. This one, the activation energy 1, and this one activation energy 2, and this one activation of energy 3. For N, and P, they are intermediate, and then for M, O, Q, they MOQ, yeah, there are transition states. So let's see the option. The chemical reaction occurs in two elementary steps. 3. MOQ represents the intermediates. No, they are the transition states. Step 1 is the rate determining step. It is correct because it has highest or bigger the activation energy. N and P represents the transition state. No, they are actually the intermediate. Consider the following data for the chemical reaction at 25 degrees Celsius. Which is the correct rate equation at 25 degrees Celsius? As you can see here from the experiment 1 and 2, this one constant, so this one 1/3, and this one also 1/3. Therefore, B is the first order. And for A, concentration of the order of concentration of A, so from the experiment 1 and 3, okay, so they are double, and this one they are also double, and this one also double, right? However, we already know concentration of, the order of reaction for B is 1. And if the order of reaction is 1, it means double the concentration, double the rate of reaction. So therefore, for the A, it will not give any effect, because if this one is already double and this one double, the rate of reaction should be quadruple if this one if the order of A is 1. So the order of A is 0, so the one that will give the effect only B. That's why the rate of reaction between experiment 1 and 2 is double. So this one is 0. The answer would be D. The plot of ln K against 1/T is shown for a chemical reaction. So the linearized expression of the Arrhenius equation ln K, RT minus EA plus ln A. So you know ln K, negative EA divided by RT plus ln A. To determine the magnitude of pre-exponential Arrhenius factor, it can be deduced from the y-intercept. So this one, y, negative 10,485x plus 25.877. This one is ln A. This one is this. So y equal to ln K, x equal to 1/T, and ln A it's 25.877. So A would be e to the power 25.877, which is 1.73 times 10 to the power 11. The answer, C. Consider the chemical reaction below. PCl3 plus Cl2 produce PCl5. Which statement about the equilibrium is correct? The removal of chlorine increased the Kc magnitude or decreased the Kc magnitude. Removing or adding reactants or products has no effect on Kc. It is only by the temperature. If you increase or decrease temperature, then Kc magnitude will change. So A and B is not the answer. The removal of chlorine shifts the chemical reaction to the product side. When the chlorine decreases, of course, the equilibrium will shift to the reactant to minimize the change. So the answer is D. The removal of chlorine shifts the chemical reaction to the reactant side. Consider the chemical equilibrium below. The concentration of hydrogen, bromine, and hydrogen bromide are mixed at 1000 degrees Celsius, and Kc is known. So now which statement about this chemical reaction is correct? So this one, Q. So Q, it's HBr to the power 2, H2, and Br2. So that would be 2 times 10 to the power negative 3 squared. So this 10 to the power negative 2 times 10 to the power negative 2. So this would be 4 times 10 to the power negative 6. 10 to the power negative 4, so becomes 2, so 0.04. So you can compare Q, it's bigger than Kc. So when Q is bigger than Kc, it means concentration of product is bigger than concentration of reactant. So when the concentration of product is bigger than concentration of reactant, the reaction or the equilibrium will reverse to the will favor reactant. So when Q bigger than Kc, the reactions shift to the reactant or reverse reaction. So the answer it's A, because reverse to the left side, so reaction shift to produce more bromine. What is the delta G value in kilojoule per mole if Kc is 2.72 at negative 173 degrees Celsius? So this one is 100 Kelvin. So the ideal gas constant is 8.31 J per K. So ln 2.72 is 1. So delta G RT ln K. So negative 8.31 times 1000 ln K, which is 2.72, which is 1 times 1. So that would be negative 8.31 J per mole. But the question asking in kilojoule per mole, so it's negative 0.831 kilojoule per mole. What is the concentration of H plus in mole per decimeter cube of 10 to the power negative 2 of calcium hydroxide? Calcium hydroxide, it has 2 hydroxide ion. Okay, so the concentration would be 2 times 10 to the power negative 2. So to find the concentration of H plus, that would be Kw divided by OH minus. So 1 times 10 to the power negative 14 divided by 2 times 10 to the power negative 2. Let's do this so it's easier. So you will get 5. This is 15. So 5 times 10 to the power negative 13. So the answer would be D. Consider the titration curve below. This one, it's weak acid, and this one strong base, because it starts from around 4. If a strong acid, start around down here, okay, 0 point something or 1 point something. Which statement is correct? It is a weak acid titrated with a strong base, and phenolphthalein can be used as an indicator. You know, when we see on the titration curve, so this is the equivalence point. So the titration between weak acid and strong base, the equivalence point is bigger than 7. So we need to use the indicator that near to the equivalence point, which is phenolphthalein. For bromophenol blue is very low, so it's not near the equivalent point. Equivalent point is around 10 or 9 something, so this is the best option. Consider the chemical reaction. Which statement is correct? AlCl4 minus accepts electrons from chlorine, which is Lewis base. So the answer, it's A. Aluminum acts as Lewis acid, and a coordinate bond is formed between aluminum and chlorine in AlCl4 minus, because it's accepts a pair of electrons, right? So this pair of electron will actually forming a bond. So this bond, it's called a coordinate bond because it is formed by having both of the lone pair forming the bond. All right. Number 29. What is the correct order of increasing strength for this 0.1 mole per decimeter cube solutions? Okay, the strength of acid is related to the ability to dissociate into its ion in water. The greater the acidic constant, the stronger the acid. So we need to find the greater Ka. So that would be the strongest acid. And for pKa here, pKa is negative log Ka, and Ka would be 10 to the power pKa, 10 to the power negative pKa. So we can estimate this one between 10 to the power negative 2 or 10 to the power negative 3, as it lies between 2 and 3. It means Y is the strongest and Z is the weakest. So the answer would be A. Consider the chemical reaction below. Mn 0 plus 2. So Mn and Ag is 0. This one negative 6. This one will be plus 1 and plus 5. So Ag reduction, Mn oxidation. So oxidation would be Mn2 plus 2 electron, and reduction, Ag plus electron, and this times 1 times 2, so it will be the same, 2 electron. Okay, so we need to calculate E cell, which is reduction minus oxidation. So from this data, plus 0.80 minus 1.18, you will get plus 1.98 volt. So delta G and Fe, so 1.98 between A and B. So this negative 2, because 2 electron, times 9.65 times 10 to the power 4 times 1.98. You will get around negative 3.82 times 10 to the power 5. It's around negative 382. So the answer would be A. Consider the electrolysis described below. Ag and fork. So Ag will experience oxidation, and this would be at the anode. This one reduction, and this at the cathode. So silver ions are formed here. It experiences oxidations, so losing the electron, producing Ag+. So silver ions are formed with the same amount of ions are reduced at the cathode, so the mass of the cathode will increase. Therefore, the answer is D. The mass of the fork increases and the concentration of Ag+ remains constant as the electrolysis takes place. What is the IUPAC name of the structure below? This would be CH2, CH2, CH3, CH3. So 1, 2, 3, 4. So this would be the alkyl. So the answer is 3-methyl but1-ene. Given the molecule X below, so this would be CH3, CH2O, C double bond O, CH2, CH3, which is C5HOO2. Pentanoic acid, it's CH3, CH2, 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 COOH, which is C5H10O2. This is the answer. Let's see ethyl ethanoate. So CH3, COO, CH2, CH3, C4H8O2 is not the isomer. Pentanol, it's CH3, CH2, 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 CHO, C5H10O, it's not the isomer. And this one is C6H12O2, also not the isomer. So the answer, it's A. Which statements are correct about combustion's reaction? They require oxygen to occur, of course. They are always exothermic. Most combustions are exothermic, but when nitrogen reacts with oxygen by breaking D and triple bond N bond, resulting in endothermic reaction. So this is not the correct answer. They always produce carbon dioxide. It depends on it is complete or incomplete. If it's complete, they always produce carbon dioxide. It doesn't mention complete combustion reaction. So it can also produce carbon monoxide or carbon. Therefore, the answer only 1. Given the structures below, which pair present cis and trans isomerisms? Stereoisomers have the same molecular formula and connectivity but different spatial arrangement. So cis and trans isomerisms in cycloalkanes due to the restrictions in the plane of the cycle. So 1.2 cyclobutane, 1.2 cyclobutane presents two possible configurations as the methyl group can be on the same site or not. And for Z is different from the options given as it is 1.3 dimethyl cyclobutane. Therefore, W and Y are exactly the same molecule as both methyl groups are on the same site, resulting in the cis isomers. So we can deduce that X is the trans isomer of W or Y, as both are the same site. So B is the correct answer. What is the correct transition state for the chemical reaction between 1-bromobutane and sodium hydroxide? 1-bromobutane, so that would be CHBr, and this would be H, and this will be C3H7, and there is OH. You can do like this here. Okay, so the transition state OH, should be the one that is between OH and Br, the one that will replace Br as a leaving group, but Br is still attached to the carbon because the nucleophile will replace the leaving group, but both of them still attached to the carbon because it is still transition state, and it should be dash line, and they should be on the same side. Okay, so the answer it's D. OH should be right here and should be a dash line. This one, there is no OH, there is no H, Br, and both A and B are incorrect answer. But for C, it should be on this side and this side, so OH and Br, so it's not on this side. Okay, which statement for the chemical reaction between 3-methylpent-2-ene and hydrogen bromide is correct? Let's do the reaction. So C double bond C, CH3 and H. This one would be CH2, CH3, right? CH2, CH3. And then this one would be CH3. When HBr react with this, so this will go here, and then Br will go here. Okay, so now there are two option or two possibility. So let's do first. This would be I will just put C2H5, okay, and this one CH3, CH3, H. So the H will attach to the first carbon, and this one will be decarbocation, and the other one this one will be decarbocation, and the H will attach here. So CH3, H, CH3, and C2H5. So now we produce with bromine CH3, CH3, bromine will be here, okay, and then C2H5, C, bromine will be here, CH3, CH, H and C, H3. So this one 2-bromo 3-methylpentane, this one 3-bromo 3-methylpentane. Which one is the major product? As you can see, this one is the secondary carbocation because it attached with one alkyl here and one C here, alkyl here. But for this one, it attached to 3 alkyl, one C here, one C here, one C here. So this is the tertiary carbocation. It is more stable, so will produce the major product. Okay, so the answer will be 3-bromo 3-methylpentane, this one. So the answer is A, because it is a tertiary carbocation, and tertiary carbocation, it is more stable compared to the secondary carbocation. Which statement about the HNMR spectrum of 3.3 dimethylbutanoic acid is correct? CH3. So let me write down the structure. CHHCO. O. This should be methyl here, and here as well. Okay, 3.3 dimethyl butanoic acid. So we'll have this one and this one and this one, the same H environment, A. This one and this one will be B environment, and this one C H environment. So 9, 2, and 1. It has 5 phenol. No, it is only has 3 phenol. The integration is 9 to 1, correct? There is a doublet near chemical shift 1 ppm. 1 ppm, it's CH3. Doublet, it is next to CH2. So it's not doublet, but triplet. There is a triplet near chemical shift 8 ppm. So this one, and for this one is next to C that has no H. So it is singlet. So it's not triplet. So the answer is B. An unknown X molecule is analyzed through mass spectrometry and IR spectrometry. The IR spectrums show a broad absorption at 3,600 centimeter to the power -1. The mass spectrum is shown below. IR is 3,200 to 3,600, which is OH, alcohol. What is the chemical formula of molecule X? So A and B, it's not. And here, it's around 45, 46. This is the molecular ion. Okay? So now, for C, the molecular formula is 60. And for D, the molecular formula is 46. So 60 is impossible because the spectrum should be right here. So the answer is D. Which combination is correct for the high resolution HNMR spectrum 3-pentanone? 3-pentanone would be CH3, CH2C double bond O, CH2, CH3. So it will have through 2 phenol. This one the same. This one and this one are the same. So it's 2 phenol. And this one will be triplet because it is next to CH2, and this one will be quartet because it is next to CH3. Therefore, the answer is C. That's all the explanation for another example of paper 1 higher level IB chemistry. I hope this video is helpful for you. for your exam preparation or for your revision. And if you find this video is helpful, don't forget to subscribe and let the other friend knows about my channel to support me. Thank you for watching, and bye.